Here is the Starbucks data from Unit 4, and I'll show in Excel how you can find the linear and exponential regression functions and build the prediction and residual table like on page 100. So if we highlight the year since 1990 and the number of Starbucks, we can go ahead and make a scatter plot. And we see here it looks like the scatter plot that we saw in the front of the activity, roughly exponential. We want to start with a linear regression. So in the chart quick layouts, I've got layout 9 here. On every version of Excel, it's a little bit different. So you're looking for the layout that says F with the X on it. And if you click on that, it gives us linear regression by default. If I want to make my font a little bit bigger, I can highlight it and make the font a bit bigger for you to read. So we see here Excel gives the equation with the slope first. So the slope is 488.11 times x. So this is, if you looked at the StatCrunch video, this is just rounded to 2 decimal places, but the same slope. And then here they've rounded the starting value to 1 place. So we want to use this equation to build the prediction and then calculate the residual. So I'll bump our graph over. So column C I've named prediction. So I'm going to go to the second row where the data starts. And in the function, I'm going to type equals, and I'm going to use my regression equation. So I'm going to say 488.11, because that was the slope. I'm putting the slope first. You could do it either way with the starting value or the slope first. Times, and then my x values are in column A. So I'm going to click on that first data point, A2. And then we'll say minus the starting value of 1,105, and I'll round it to 1 place like Excel does and say it's 0.7. If you round to different decimal places, that's fine. Your values will be slightly different, but we'll still see the same overall trends. Then we can go ahead and press enter once we've got our equation in there. So if we want to extend this equation down, go ahead and click on the equation and drag the corner of that cell down, and it fills in the prediction for years 0 through 13. For the residual is the observed or actual values, which we have in column B, minus the prediction values, which we have in column C. So we can say here, the residual equals, and I'm going to click on B2, and then I'm going to say minus C2, and that subtracts those values for me. And then to extend this down, I click on the corner and drag it down. And here we've got the residuals for all 13 years. So these are the values that you want to put in your table on page 100. If you want to pause, you could copy them down. Question 2 asks to make a scatter plot of the residuals. So we want to have years since 1990, and then you can hold down Control or Command and also highlight the residual column. We want that to be our output. And then if we go to charts and choose scatter plot, you don't want to choose a connected scatter. Make sure you're just picking just those scatter dots. We see our residual graph. And if we look side by side at the residual graph with the regression graph, we see the linear regression is not a good fit for this data. So the line is coming through the data for low values of years, around year 0 to 3. The line is an underestimate, so it's got a positive error here. And we see that in the residuals trend, the positive errors over here. In the middle years, the line is above, so we've got negative residuals or negative errors, and we see that pattern in the graph here. And then in years around 11 through 13, again, we've got positive errors, and so we see that trend over here in the residual graph. So when the residual graph has a pattern like this, a readily discernible pattern, we say it's not a good fit, meaning the regression equation is not a good fit for the actual data because there's too much of a pattern in how the errors are computed. And we can see that because it looks like this data is much more of a curve. So I'll delete our residual graph. And then if we want to do exponential regression, we can come over here to our linear regression equation and right click. And you can say format trend line. And then I'm going to choose exponential and say OK. And where's my exponential function? My exponential function didn't pop up. Maybe because I messed with the font. So let's see. Let's go back and make the linear regression and then format trend line and change it to exponential. There we go. Now it's coming up. So our exponential function is in terms of base e. If you would rather have it just in terms of a base, you could type e to the 0.3508 in your calculator and rewrite the function that way. And so we see the starting value for the exponential prediction is around 97, and then we see this is how it's growing. It does look like it's a better fit, so let's go ahead and move our graph over, and then we'll make an exponential prediction. So here we can type our equation equals, and I'm going to put in the exponential function, 97.564, then we'll say star for multiplication, and then for the exponential you have to type exp, and then in parentheses we want 0.03508 times whatever value the year since 1990 is. So I'm going to go ahead and say A2, close my parentheses and press enter. So here's my exponential prediction. If I want to extend this down, I can click on the corner and drag down. And we see here's our exponential predictions. Now if we want the exponential residual, we can come over to the next column, and that's going to be the observed values or the actual values in column B, minus the exponential prediction that I put here in column E. So we'll say that equals B2 minus E2. You can of course do this by hand once you've got your tables filled out. It's just a bit faster to let the computer do the work for us. Okay, and we see here it's still not a perfect fit because we've got quite large residuals, but it looks a little bit better. And if we go ahead and make a residual plot for this, which you are asked to do, I believe on page 102, to think about it. Oh, you don't have to, but if we did make a residual plot, let's do that real quick. You'd highlight, I'm sorry, year since 1990, and then you'd highlight also with Control or Command the residuals, and you'd make a scatter plot. And we see, well, not great, this is still a slightly better fit than not too much of a pattern than we saw with the linear regression, but still not a little bit worrisome because it looks like there's a bit of a trend. Okay, if you, instead of using the exponential form of the equation, if you figured out the exponential of 0.3508, that base is around 1.4202. So if you did it that way instead, when you enter your equation, you would say times, and you could put in parentheses, 1.4202. And then to get up in the exponent, you'd hit this exponent key above 6, and then you type A2 in the same way. And you can see that gives us almost the same prediction, give or take some rounding. So if you prefer to use that form where you've evaluated the base to be the 1.4202, that gives us the same results.